Heavy structural steel and engineering machinery parts need long, multi-pass welds on thick plate. Skilled welders are hard to hire, and inspection still rejects bad seams. How do you automate it? Thick plate welding has three classic problems. Multi-pass layers trap slag or fail to fuse. Large parts have faces a fixed robot cannot reach, and a skilled welder's touch is hard to clone. The 10th part and the 1000th drift apart fast. This cell pairs an industrial robot with arc and seam tracking. The torch locks to the center line of the joint within plus or minus 0.5 millimeters in real time, holding parameters constant across the full seam. Multi-pass passes are laid layer by layer with controlled interpass temperature and weave parameters. Heat input is steady, and slag inclusion, lack of fusion, and undercut drop sharply. A dual-axis U-type positioner rotates the part to the optimal flat gravity position, and the welding cell scales to up to 16 external axes. Add a robot travel rail, and a large frame is welded all around in one setup. The payoff comes down to three numbers. First pass weld acceptance above 99%, 2 skilled welders displaced per cell, and 24-hour 2-shift welding with no operator fatigue. The same logic carries over to structural steel, bridge box girders, engineering machinery frames, pressure vessel shells, and railway bogies. Every heavy thick plate part fits the workflow. However thick the plate or many the passes, the robot welds them all to the same line. This is EVST. We make thick plate welding automation real.